Sometimes it's easier to work with exponents and sometimes it's easier to work with roots. And these two pieces are interchangeable. So the power is the numerator and the root is the denominator. So if I'm going to rewrite this, this is the second root of 9 to the first power. Well, second root is just leaving it blank and it's the same thing as the square root. And the square root of 9 is 3. So the next one, I have the second root or the square root of 9 to the 5th power. Well, 9 to the 5th power is the second root of 59,049. Well, let's see if that has a perfect square. And in this case, my answer is 243. Now, I highly recommend using a calculator. And a calculator, you can do it one of two ways. You can take the square root of this, or if you're going to put this piece in your calculator, you need to say 9 raised parentheses 5/2. The last one here is the third root of 343 to the second power. Well, 343 to the second power is 117,649, and I want the third root of that. Well, one way you can do that is start with 117,649. Is not divisible by 3. Let's see if it's divisible. It's not divisible by 5. Is it divisible by 7? And the answer is yes. So I can divide it by 7, which is 16,807. Let's see if it's divisible by 7 again. Sure is. 2,401. Is it divisible by 7 again? Sure is. 343. Divisible by 7 is 49. Divisible by 7 is 7. And 7 is 1. So let's see if we can get this. We have a group of 7s, a group of 7s, because we have to put them in groups of 3. And 7 times 7 is 49. So if you don't have a button in your calculator, you can always break it down using the roots from exponents. Look at it in another way. Could I break it to exponents? Or is it in exponents? Could I break it to roots? Absolutely. Let's start. 2 times 2 is 4. Now let's go back to something we know. If I had x to the 4th times x to the 3rd, that means there's 4 x's and 3 x's for a total of 7 x's. I added my exponents. So let's do the same thing here. 3/4 plus 1/5. And I get x to the 19 over 20. Now, if it says for some reason I want it to be written in root form, then you would write 4 the 20th root of x to the 19th. These are the same answers. Last problem here, let's look at division. So I have 4 divided by the 7th root of x squared. Now, if I want no radicals in the denominator, I'm going to have to multiply it by something so that when I do that, I get the 7th root of x to the 7th, so that these pieces will cancel. So if I have 2 x's here, that means I need 5 of them, because 2 plus 5 equals 7. What I do to the bottom, I must do to the top. So when I multiply across on the top, I get 4 7th root of x to the 5th. And on the bottom, I get 7th root of x to the 7th. Well, these pieces cancel, and now on the bottom, I get I get x. And on the top, I get the 4th root, 4 times the 7th root of x to the 5th.